morning, everyone. This is M. Venkatesh, Assistant Professor in Electrical and Electronics Engineering, PVR WITS, Kavali. So, last video we will we will discuss about the electrical technology and introduction of the DC generator and what is the working principle of a DC generator is that in this video we will discuss about the constructional details of the DC generator. So in the constructional details of the DC generator is same for the DC motor also. That's why the constructional details of the DC machine. So here the constructional details of the DC machine like this. So this is simple view of the cross-sectional view of a DC generator. So here you can simply see here. So yoke. See here yoke. So what are the parts consisting of DC machine? So what are the parts consists of DC machine? The first one is yoke. It is the outermost layer. Yoke is outermost layer, and next we can see it the poles. Poles is nothing but like this. It is a magnetic poles. Poles are magnetic poles. These poles for field winding. So for field winding, and then so next one is field coil or field winding. Next we can see armature. Armature is like this. This is the armature. And next that is a commutator. This is the commutator inside the layer. That is a commutator. And next we have the brushes. So like this. And next we have the bearings. So here what is the yoke? Yoke is simply consists of it is the outermost layer. It is the outermost layer. It protects the total inner body of the machine. It is made up of cast iron or silicon steel. Cast iron or cast steel or silicon steel material. So this layer protects from the outer atmosphere conditions or dust, fume, or whatever the conditions. So it is protect the total machinery. Coming to poles, these poles are classified, that is designed with pole core and pole core with pole shoe. So pole core with pole shoe. So this pole core is useful to support the field winding. And pole shoe is it expands the fluxes to the air gap. It expands the flux to the air gap. What is the air gap? Air gap between this. So see here. So the pole shoe and between here pole shoe and armature. So between some gap is there. That gap is called so air gap. So this induce the flux lines so that passing to the air gap. Okay, so that is so this always these are the poles. Like here you can see 4 poles. And next field winding. This field winding on the poles on the magnetic poles. It is the coils. Okay, copper wire. Okay, so next armature. Next one is armature. So the armature is a simply circular, that is a cylindrical shape. This cylindrical steel, that is a cast steel or cast iron. So this cylindrical steel designed with a slots, this like this. So cut pieces as a slots. So this slots is useful to place the conductor, that is the armature winding, that is a copper winding. Place that copper winding. So this is the armature. Next commutator is there. So this commutator is useful. We know this loss, that is an alternating EMF converting to direct current EMF, DC EMF, that is AC into DC conversion. So the commutator is useful for this conversion of AC into DC. And what is the brushes? Next one is brushes. This is made up of simply what? Carbon material. So this carbon material is very lightweight material. It's a very lightweight material, and this is placed on the commutator, and it corrects the current. And it is placed. It is the terminal. And bearings. So last one is bearings. That is, the bearings is simply useful for free movement of the armature. Free movement for the armature. So that is a free rotation. Okay. So coming to next, we can see what is the yoke. Yoke, it acts as a protective layer. It acts as a protective layer. It protects from the dust, fuel, and everything. So this is, so you can see this is the yoke. So this is placed yoke. It's the outer layer, that is the outer frame, and it is placed on the stand. Okay, so like here. So this is the yoke. So it is protect from the outer dust and fuels. This is made up of material cast iron or cast steel. Next we can see poles. The poles are two poles are consists of pole core and pole shoe. Poles are consists of pole core and pole shoe. So here poles are consists of pole core and pole shoe. So see here. So in the pole shoe, this is a pole core. This is the pole core. So this is a fixed poles. So through bolts we can fix the poles on yoke. So these poles are fixed with laminated. That is the one layer, another layer. That is a coated layer. So to protect from the losses, and this core useful for the wound the copper coil. That is a field winding. So, and this pole shoe, when the current passing to the coil, they produce the flux. So that flux enlarges the space. That means releases through the pole shoe. This pole shoe has the shape of curve. So due to this shape, so that minimum flux can expand to the maximum area. So that's why the poles are placed like this. Poles are so placed like this. Okay, so next this next one is going to be field winding. So the field coil or field winding placed on the pole. So placed on the pole. Why? Because we are placing on it is a stationary field. So there is no rotation. There is no rotation. So this stationary field can produce the stationary flux from north pole to south pole. Between the poles, they can produce the stationary flux. So this pole core wounded on the field winding. So the field winding wounded on the pole core. Okay. So next we can see the armature. So the armature can design with slots. Armature can design with slot. This armature consists armature core and armature winding. So here, see here. So a cylindrical shape of a metal piece. So that cylindrical shape designed with slots like this, step by step manner. So this outer layer can cut it by the like these slots. So these slots useful for placing the copper winding. So placing the copper winding, that is a conductors. Placing the conductors, that is the armature conductors. So and also here this cylindrical shape having a holes, that is a hose. These holes useful for the air hose, that means air ducts. So this total armature laminated by a layer, that is a silicon layer, laminated by a oxide layer. So due to this lamination, so to protect from the leakage losses, that means leakage flux losses. So there is no leakage fluxes due to the lamination of the core. Okay, so this is the armature. So coming to next, the armature windings. So the basically the armature winding on placed on the armature slots, placed in the armature slots. So in the armature slots, placing the armature conductor. The conductor is nothing but armature winding. So this armature winding have designed with two types, that is a lap winding, wave winding. So here see, observe the lap winding like simply like this. That means coils, simply coil structure, that is a closed path structure. So that is called a lap winding. And wave winding means simply it is a wave nature. Simply it is a wave nature, that is a wave winding. So in this lap winding to overlap the nature, that means coil nature. And this is here the number of parallel paths equals to the number of poles. So how many poles we have that? that number of parallel paths are there. But in the wave winding, they consisting of only two parallel paths, only two parallel paths. And also the lap winding is only used for high currents and low voltages. Lap winding is only used for high currents and low voltages. Where the high currents are required, we can use the maximum coil structures. That means lap windings. Where the high voltages are required, we can use the wave winding. So that's why the lap winding is used for high currents and low voltages, and then wave winding is used for high voltages and low currents. Okay, so next we can see the commutator. So commutator is nothing but simply an arrangement with split rings. So these split rings are connected to the armature. So where the conductor, that means where the induced EMF in the armature, that is the alternating quantity, that is the AC, that AC quantity may convert into DC quantity, vice versa. So that is used for commutator in the DC machines. So that's why the alternating quantity convert into direct quantity by using a commutator in the DC generator. That converting from converted current may again collected to the brushes. Okay, so then this is made up of copper. And coming to next, brushes. So these brushes are arranged on the commutator. So where the commutator converts AC into DC, so that DC collects from the commutator by using the brushes. So these brushes are made up of carbon metal, and then so this armature, that is this DC machine also have in the last part having the bearings. So these bearings are like this. So it is the outer last metal. This is a simply connect the shaft to another material. So this shaft on the bearings. So these bearings are wheel movement. So for wheel movement, it's the rotation movement. So the free rotational point of view, we can arrange the bearings. Okay. So this is the constructional details of the DC machine. So in this DC machine, actual, for example, you can see like here, this is a simple structure of armature. So armature of DC machine, this is a ball bearing, this is a shaft, and here we have that number of slots, and it is a coil commutators. Okay, so interconnection of this. Okay, so this is the outer layers. Okay, so here it is a copper coil. It is a copper coil, and it is a iron core. It is simply armature. Okay, so this is the constructional details of DC machines. Okay, so again, so DC machines have that, so basic things, that is a yoke, poles and field winding, armature winding, commutator, brushes, and then bearings. These are the construction parts. Okay, so in next video we will discuss about the how to drive the EMF in the DC machines and what are the problems under the EMF